All right, so here's from the workbook. This is page 30 and 31. Okay, notice that this is part A. There is a video with a part B, so if you'd rather watch the video of part B first, then try to do this one, and then watch the video to check your work, that would honestly be the best option for the learning anyway. Okay, so let's take a look at this. What units would you use for the rate of each scenario that follows? Okay, so units in terms of like, would you use miles for distance, or kilometers, or meters, or inches, or centimeters, that kind of stuff. So riding a bike, typically we would want to use miles for that. Okay, because when you're riding a bike, you're generally traveling miles. So centimeters would definitely not work. Rainfall during a storm, usually that's reported in inches, because most of the places, at least around here, we're lucky if we get an inch. I suppose in some areas milliliters would be another one. In some areas, maybe even feet. Usually we talk about snow in terms of inches and feet, but rain is generally inches. Okay, water coming from a fire hydrant. Okay, this is different than the rainfall because most likely we're getting a lot more. Okay, so we'd probably want to deal with gallons. Okay. Watching caloric intake. Okay, that's actually calories. I don't know of any other way to deal with that one. Okay, so there we go. All right, now for the next, we're going to write an equation, then use that to solve the problem. Okay, making sure to use appropriate units. So, you need to buy a new tile for your kitchen. The kitchen measures 13.25 feet by 7.5 feet. Okay, so what is the area of the kitchen that you calculated? What is the most accurate area you can report to your hardware store in order to purchase enough tile? Okay, so we would, if you need to, draw a picture. So you've got your kitchen. It's 13.25 feet by 7.5 feet. Okay, so what is the area of the kitchen that you calculated? What is the most accurate area that you can report to your hardware store in order to purchase enough tile? So our equation would simply be area equals 13.25 times 7.5, right? Because area is length times width. Okay, then I grab a calculator to make this calculation easier. So 13.25 times 7.5 would give me 99.375. Okay, and that would be feet squared, right? So, maybe 100 is the most accurate, 100 square feet. If we're talking about accurate, this would be accurate, but typically you would end up being more based on the fact that you won't use a full tile sometimes, depending on how big the tiles are. Anyway, so number 3. Zach watches TV 3 times as much as Joel. Joel watches TV 2 hours a day. How many hours a day does Zach watch TV? So we want to know Zach. He watches how many hours? Okay, well, he watches 3 times the amount that Joel does. We're told Joel watches 2 hours a day, so I should just have 3 times 2. So Zach would equal 6 hours a day. Okay, number 4, it costs Raquel $5 in tolls to drive to work and back each day. Plus, she uses 3 gallons of gas. It costs her a total of $15.50 to drive to work and back each day. How much per gallon is Raquel paying for her gas? How do you know? Okay, so she paid $15.50 total. Okay, now we know that no matter how far she had to drive, she has to pay that $5, no matter how much gallons she used. So we have that $5 plus she's going to add to that 3 gallons of gas. Okay, so for G, we'll say that's the cost of gallons of gas, and it's per gallon, so 3 gallons would be 3 times G, plus 5 would equal 1550. So subtract by 5, we get 1050 equals 3G, divided by 3, and 1050 divided by 3 is 3.5, or in money, 350, because if we're dealing with money, we make it always to the hundredth. So, 350 per gallon. And how do we know? Well, we just figured it out. Okay, number 5. Hayden bought 4 tickets to a football game. He paid a 5% service charge for buying them from a broker. His total cost was $105. What was the price of each ticket, not including the service charge? Wait. What was the price of each ticket, not including... Okay, got it. So, we know he bought 4 tickets. Okay, we don't know the price of each ticket, but I know that 4 times T would give me the total price of tickets. He also paid a 5% service charge for buying them from a broker. So, if we think of that 4T as being 100% of the ticket cost, we had to pay on top of that 5% of that cost. Okay? So, 105% is really going to be our total cost. Well, 4T is only 100%, so we'd have to add to that 5%. Okay? Or, in other words, that's like 1.05. If I take that amount and times it by 1.05, that's going to give me my total amount. So I could, for my equation, just go like this. Or I could simplify that and get, it's really 4.2 per the cost of each ticket. So I go 105 and then we divide by 4.2, right? So divide by 4.2, and we end up with $105, or 105, 25, duh. $25 per ticket. So each ticket costs $25. Alright, 6. It costs Justin $100 to have cable TV installed in his house. Each month he pays an access fee plus a tax of 7% of his monthly bill. After 6 months, Justin has paid a total of $350.38 for his access fee, taxes, and his initial installment. What is his monthly access fee, not including taxes? So, we know he paid $350.38. Okay. We know that he had to pay this $100. And on top of that, he's now paying for his access fee. We'll call that A. Okay. This is including 6 months of that. So he paid 6 months of his access fee plus 7% of that access fee. Okay. So if I take 6A and I times that by 0.07, okay, that's going to give me how much more I paid in, or he paid in his fees. Okay. So that ends up being 0.42A. So I can combine those and get 6.42A plus 100. That's going to equal to 350.38. So we subtract 100 from both sides. We get 250.38 equals 6.42A divided by 6.42. So 250.38 divided by 6.42 gives me 39. So he's paying $39 for his cable. I don't know if that's good or not. I don't have cable. Okay, number 7. Okay, you and 3 friends divide the proceeds of a garage sale equally. The garage sale earned $412. How much money did you receive? Okay, so I take 412, and we're going to divide it by 3, right? Oh, you and 3 friends, so 4 of us. And that's going to equal how much money I receive, okay? Or we could also say 4 times the amount of money we each receive should equal 412. Regardless, I'm going to end up going 412 divided by 4. And we each got $103. Okay? Number 8, the area of Sophia's herb garden is 1/2 the area of her vegetable garden. Okay, here's veggie garden, herb garden. The area of the herb garden is 6 square feet. So 6 square feet. What's the area of her vegetable garden? Okay, so if we take her herb garden, okay, or it's 1/8 the area of her vegetable garden. So I know that if I took her vegetable garden and I times it by 1/8, it would equal her herb garden. Okay, her herb garden, we know, is 6 square feet. So we would just times both sides by 8, giving us 48 equals V. So her vegetable garden, 48 square feet. Okay. Number 9, driving to your friend's house, you travel at an average rate of 35 miles per hour. On your way home, you travel at an average rate of 40 miles per hour. If the round trip took you 45 minutes, how far is it from your friend's house to yours? So, you've got the house, right? You go there, you come back. Your friend's house. We don't know the distance. Okay? We know that it was 35 miles per hour one way, 40 back, and a total it was 45 minutes of time. Now, anytime we have distance and rates and times, we have this formula, distance equals rate times time. Okay? So, the time it took us was 45 minutes, right? Okay? But we accomplished that with 2 different speeds. Okay? So, the way to think about this is that had I gone 45 minutes, okay, if it was 60 minutes, that would be like, an hour. If I traveled at 60 miles per hour in 60 minutes, I would have gone, oh my goodness, I'm getting myself mixed up. All right, let's think of it this way. So, at 35 miles per hour, he can go 35 miles in an hour. 40 miles per hour, okay? So, the way to think about this is that distance is equal to the rate. Now, it's in minutes, so remember that. Okay, 45 minutes, and then it's miles per hour. So we go 35 one way plus 40 the other way. Okay, there's our equation. We add 35 and 40 together. Gives us 75 times by 45, and we get, I believe it's, let's do this, 45 times 75. That's 3375. Now, that's not in miles per hour because, and I guess we have to take all that and divide it by 2, don't we? That's in minutes, not in hours, okay? So we then would need to divide, so we get 1125, divide this by 60. Oh crap, no we didn't. I wrote it wrong in my calculator. Be 1,687.5. Divide that by 60 because we're dealing with miles per hour, not miles per minute. So it would end up being 28 miles. Alright, let's take a look at the last one. So, 2 trains are heading toward each other and are 400 miles apart. So let's draw these trains. Train 1, train 2. Okay, so we know that's 400 miles. One train travels 15 miles per hour faster than the other train. Okay, so let's say this train is going X miles per hour. So this would be X plus 15 because it's 15 miles faster. If they arrive at the same station in 5 hours, so station, okay, in 5 hours, how fast is each train traveling? Okay, So we're going to take their two speeds, okay, which would be x miles per hour and x plus 15 miles per hour. Their two speeds, because they're traveling over that 400 miles in the same distance, okay, we'd add those together. Because what we're using here is that distance equals rate times time, okay, this would be the rate. They did it in 5 hours, and they're traveling 400 miles. So I can simplify first. So 2x plus 15 times 5. 5 times 2 is 10x. 5 times 15 is 75. So 10x plus 75 would equal 400. Any one of these versions of the equation work. And then we solve, subtract by 75, and we get 325 equals 10x, divide by 10, and we get 32.5 equals x. So one train is going 32.5 miles per hour, the other one would add 15, and it would be 47.5 miles per hour. And there we go.